So now we're looking at radical equations where there is a coefficient in front of the radical. There are two ways to go about solving this. As a check, we're going to use a second method instead of substituting and simplifying as we normally would. With our first method, we're going to isolate the radical just like we have in the past. This is going to involve division since we're multiplying by a coefficient. So if we add 16 to both sides with 2 times the square root of 4a plus 4 minus 16 equals 16, that's going to give us 2 times the square root of 4a plus 4 equals 16 plus 16 is 32. Now we'll divide both sides by 2 to give us the square root of 4a plus 4 equals 32 divided by 2 is 16. So now we square both sides. The square root of 4a plus 4 squared is just going to be 4a plus 4. 16 squared is 256. Now we have a basic linear equation that we need to solve. So subtract 4 from both sides, we get 4a equals 252. Divide both sides by 4, and we get a equals 252 divided by 4 is 63. So now we're going to look at what if we don't isolate the radical itself, but we square once we have multiplication involved on the left-hand side. So let's go ahead and skip to our second step since the first step is going to be the same. And we're going to have 2 times the square root of 4a plus 4 equals 32. And now let's just go ahead and square both sides from here. So 2 squared is 4, 4a plus 4. The square root squared is going to be 4a plus 4. And then 32 squared equals 1024. So now we can go ahead and we can multiply through, or we can divide by 4. Let's just keep what's on the left and multiply through. And we end up with 16a plus 16 equals 1024. Subtract 16 from both sides and we get 16a equals 1024 minus 16 is 1008. Then finally divide both sides by 16. And we get the same solution. 1008 divided by 16 is 63. So a equals 63. And again, we could use either method in this case, or we could simply substitute 63 back into the original equation to verify that it yields a true statement.